Hello, I'm Mark Dickin, Head of Additive Manufacturing and Applications here at Ricoh Printing Solutions Europe, the home of Ricoh 3D. Since 2021, we've been developing our unique aluminium binder jetting technology powered by Ricoh's inkjet expertise and Gen 5 printheads. Aluminium binder jet printing is a technically demanding area. Collaborating with our R&D team in Japan, Ricoh 3D is pushing boundaries to target thermal applications that not only advance this technology, but also help tackle social challenges and contribute to a more sustainable future. Continue watching as we share more about Ricoh's aluminium binder jetting vision, our dedicated Metal AM Customer Experience Centre, focus applications, an overview of our end-to-end processes, the benefits for you, and real-world case studies with insights from our metal engineering team, Myles and Insei.
Welcome to RPSE. Come with me and I'll show you what Ricoh 3D's Metal Binder Jetting Facility, or CEC, consists of. Okay, so the purpose of this facility is to act as a collaboration hub between our Japanese team, any potential partners and interested third parties who are wanting to understand the benefits of the technology and help us develop the technology further. So this is our beta system. This is the start of the process for collaborative projects with our customers or the R&D team in Japan. This uses Ricoh's Gen 5 printheads and a combination of our proprietary aluminium powder and binder. We will print parts in this system and will produce a green body, which is the first stage of the process. And this is the sort of thing we are able to produce with our technology. Once the part has been printed, it will then come out of the printer and go into the drying oven for about 24 hours to dry the parts before we then take them out of here and place them in our bespoke Additive Blast depowdering station, where we do the bulk of the depowdering. From there, once all the powder has been separated from the rest of the parts, we then move down to the sintering process and we produce our finished sintered parts. And this is an example of that as well. So our process enables us to produce parts with a density of around about 98% and a shrinkage rate of roughly between 10 and 13%. The benefits to our process involve being able to produce high performance, high density heat sinks and heat exchangers that have the ability to provide performance benefits for a couple of different sectors. Specifically, we think the EV sector, where there's a big push to lightweight components for the battery and inverter heat sinks, which then reduce wear on batteries, tyres, the weight of the vehicle, and which then can increase the range. And also the aerospace sector, who are under heavy pressure to decarbonise and reduce the weight of their components as well.
As Mark and Myles explained, the focus of Ricoh's binder jetting technology is thermal management. We are looking to work with customers and co-create parts and applications which support sustainable future through a more effective thermal management. Such application includes heat sink, heat exchangers, and cooling plate, and more. Have you got any applications that you think could be suitable for this technology? Let us know and we can discuss co-creation opportunities. This is liquid cooling heatsink plate made by aluminium binder jetting and diffusion bonding technology. The traditionally manufactured copper heatsink could be replaced by aluminium. You can see the weight difference. So on the binder jet heatsink, the fin designs has been optimized, and on actual testing, it showed better cooling performance than copper pin-fin heatsink. Also, thanks to the diffusion bonding technology, the printing size has been optimized for binder jet process, and the manufacturing cost has been reduced to the same rate as copper heatsink. Here's some further example of applications and parts. To help realize the effectiveness and true potential of aluminum binder jetting applications, we work in tandem with our customers and partners on the entire development process, from design support to manufacturing and achieving realistic cost, which are integral to the ambition of mass production.
I hope you found these insights from the team useful. We're now looking to collaborate once again with customers and partners to truly understand market needs and your components, applications and pain points. By working together, we can develop the technology further, helping to shape the future of metal additive manufacturing industry and manufacture your applications at scale, supporting the realisation of a sustainable future. Get in contact with one of the team today. Visit our website 3d.ricoh.com or connect with us via LinkedIn.